Imagine asking one question and instantly uncovering how every company executive and product in your data is connected. We're not talking today about RAG, we're talking today about GraphRAG. In this video, we will go step by step through how the code extracts entities, builds relationships, and transforms plain text into a living knowledge graph with Neo4j and Python. At the end, we will explore all these patterns here, relationships, to see how they interact. And this is all based on a text. Our journey today has 6 steps. First, anti-extraction, then relationship mapping, cleaning the data, converting triplets into Cypher queries so that we get the text into what we see here, the Neo4j graph, and then the building at the end, the knowledge graph to ask questions. So the next step from standard graph, which we all know from text to vector stores, here we put the text to graph. And so we're turning raw text into insightful answers. So let's dive in and see how we can build it. First, as always, we need to import some packages. So we have model name, we use GPT-4.1, we have our key, and then a list of Python packages. We have spaCy, LangChain, and at the end also Neo4j, because of course we need to connect. So what do? We create a connection to our local database. So for that, we need just to install Neo4j. Then we doing the connection with these 5 lines. So Neo4j graph URL, which we set here on top, the username and the password. Then at the end, we have the connection to Neo4j. On top of that, we have NLP, spaCy, with the English corpus, so to extract English informations. And then we have the LLM. In this case, OpenAI, to discuss with it with 0 temperatures, so no randomness. So first, we use spaCy, so the entity extraction. We start with entities because those nouns in the domain, people, organization, products, and locations using the NLP library, we need first this base because we process the text from a document, from a downloaded text, whatever it could be, and we're extracting entities, person, organizations, products, and so on. At the end, we have an output which is clean, a unique list of entities. For example, instead of mixing up Apple corporate, so the Apple company, and Apple, the fruit, the system correctly identifies the company, and this is really a foundation, really important for the graph itself. Afterwards, we need to extract relationships. And this we're doing with, so here we wrote a prompt, so we give the entities, and then we're telling, okay, can you build us the relationship? And what makes the graph powerful are the relationships at the end, and this is the core of a graph. You have dots, and you have dots on the other side, and there between you have already. And here large language models shine, because the system prompt we give to the LLM extract factual triplets. So entity, entity, and relationship. For example, in our text, we wrote the future bank launched Novalet, or the future bank is based in Berlin. So we have the node future bank, we have the node Novalet, and in between we have the connection launch. So the relationship between those two ends. Step 3 is the cleaning and preparing data for the graph. Before inserting into Neo4j, we clean and prepare the text. This means removing unnecessary characters, ensuring consistency so that Cypher queries, the language of graph database, won't break. A small but essential step for keeping our data reliable, because we know bad data in, bad results out. Then we're converting the triplets to Cypher queries, because so far we were really outside of the world of Neo4j. We were reading a text, we were extracting the entities, we created the relationships, so we have triplets. But now how we get this into Neo4j? We need to create a Cypher. That's the language Neo4j understands. And therefore, we're creating now those Cypher language queries in order to import our triplets into Neo4j. So for each triplet, the system checks if the entities already exist in the database or not. If not, it creates them. Then it establishes a relationship like future bank launch Novalet, as we heard before. And this approach avoids duplicates, keeps data consistent, clean, and sure the graph is auditable, ready, and so on. So we have a clean, scalable, and reliable Neo4j database. At this point, Neo4j brings everything together. So entities, the dots, relationships becomes a connected knowledge graph. Imagine seeing all your company's executives and products in one living map, what we see here. For example, future bank launched Novalet. Dr. Jamie Lin developed Novalet. Now your data is just not stored, it's connected and ready to answer questions. And last but not least, it's the execution, so from text to insights. So let's scroll down, let's see the action, because here we already extracted everything, triplets and so on, and then we go for asking the questions, and there we see it in action. So we ask questions such as, who is the CTO of FutureBank? Jamie Lin is the Chief Technology CTO of FutureBank is headquartered in Berlin, and so on. And this we can then compare with our data to see if it's correct. And if this helped you, explore the full article and resources on AI Finance Club. Subscribe to the webpage by getting access to exclusive masterclasses, articles, and more. If you have any other questions, feel free to contact me. My name is Christoph Watten, and I hope this video about GraphRAG was insightful and helpful for you.